I'm Ole-Steinar, and I will talk about what I did in my master thesis, where I looked at how to use recurrent neural networks for session-based recommendations. And if anything is unclear, you can just interrupt me and ask. So, some example problems that we want to solve is to recommend subreddits to users of Reddit, or recommend items in an online grocery shopping service, or recommend songs in a music streaming service like Spotify, or any similar problems. But the three datasets that I used was from these examples. So we assume that we have access to the history of user actions, and that it makes sense to split a user's history into sessions. And a session is just a set of consecutive user actions that are related to each other. So for example, if you're listening to music at work and then later listening to music while at the gym, then that would be two different sessions. And it's not always easy to say where one session ends and the next one begins. This will depend on the domain, but it's usually okay to set a time limit for the temporal distance or the time between two consecutive user actions. So we want to build a recommendation system that is able to consider both inter and intra-session dependencies between user actions. So when we make a recommendation, we want to consider the dependencies between the user actions within that session, and also consider dependencies on actions from earlier sessions. And the user action can be anything as simple as an interaction with an item, such as listening to a song, or something more complex like a free text search. We will keep it simple and only consider the actual item interacted with. So we just use the item ID. The illustration at the bottom shows three sessions where the circles represent items, for example, songs. There are at least two types of recommendations. We have novel recommendations, where we try to help users discover new content that they hopefully will find interesting. And we have predictive recommendations, where we try to help users find what they are already looking for, but faster. And if you want to do novel recommendations, you need some form of user feedback on your recommendations. So typically some form of rating from the user on the recommended item. But if you only have access to a dataset, then you can't do predictive recommendations, since you don't get any feedback on your recommendations. So that's what we will use. Because then we only need to know the next item in the session, or the final item, because we assume that that is what the user is looking for. But if you wanted to do novel recommendations, then the system itself would be very similar. It's mostly the training that's different. So how can we predict actions by considering the previous ones? We could use a classic neural network that takes the previous action as input, but the next action might depend on any number of the previous actions. So we would have to expand our network to accommodate this. So we could decide how many of the previous actions that should be considered, and then feed them all as input. So this does not scale very well, and also it does not really consider the order of the actions. And since the sessions can have different lengths, it would be nice to have a more dynamic model that doesn't assume a fixed length. And we can solve these problems by using a recurrent neural network. The classic neural network has no memory between inputs, while a recurrent neural network is a neural network that has a memory state that is kept between inputs. So here x is the input vector for time step, typically a representation of the item, such as a song. And the RNN is just shown as a black box here. And Y is the output vector, which contains the recommendations. And I won't dive too deep into the technicalities here, but you can think about the RNN like a normal neural network that has a additional memory input that it receives from the previous time step. So the memory is a vector that gets updated based on the input x at each time step. As an example, you could consider a user browsing a web shop looking for computer parts. So he might want to buy a new hard drive and a processor. So while the user is browsing for these items, the RNN learns about his interests. And then if the user he decides on a processor and adds it to his basket, then the RNN can use this information and update its memory with the information that he is no longer looking for a processor. So the recurrent neural network can learn about the user across multiple time steps. It takes the current item and the memory from the last time step as input. It outputs recommendations and an updated memory vector. It stores what it knows about the user's interest in the memory vector, and it's not restricted to a fixed number of time steps. So initially, the recurrent neural network won't know anything about the user, but as the user interacts with the items, the network learns about the user and his interests. So when we are training a RNN, we have to set a limit for how far back in time we want to propagate the error. But when the RNN is performing recommendations, it can take on sessions of any length because it only needs the memory from the previous time step and the input in the current time step. So recurrent neural networks are a really good fit in this session-based recommendation scenario. And many recent papers have shown that RNNs can significantly outperform state-of-the-art recommendation models in the session-based recommendation scenario. So our RNN learns throughout the session and it's able to provide strong recommendations after having observed some interactions. And it can make those recommendations based on the previous user action, or maybe that one isn't too relevant. So it can make the recommendation based on earlier actions. And this information is stored in its memory. And the RNN might discover patterns, which makes it able to predict what you will do next. For example, which song you will listen to. So everything is good, except for the first few time steps. Because before the RNN has had some time to learn, it will not be able to provide strong predictions about your interests. Especially for the first time step, where the RNN has no idea about what your first music choice will be. So our RNN takes in each song you listen to and produce a list of songs that it believes you most likely will listen to next. And initially it can't give us strong predictions since the memory vector has no values yet. But we are free to initialize the memory vector as we please, so we just need a smart way to do it. And in the same way that the user actions within a session are correlated, it seems reasonable to think that there are correlations between the sessions as well. So let's say you order a laptop online, and then later you are looking for some accessories to your new laptop, but you will definitely not be interested in another laptop in the near future. So this shows how information from one session is relevant to the recommendations in later sessions. So how can we use this information from earlier sessions to set the initial memory vector in a new session? Well, in the same way that actions within a session forms a sequence ordered by time, the sessions themselves forms a sequence ordered by time. So we could use a second RNN to process the sequence of sessions as well. So here we have the inter-session RNN, which works with dependencies between sessions to produce the initial memory for the intra-session RNN, which works with dependencies within a session. And to make the terminology a little bit less confusing, I will refer to them as the between session RNN and the within session RNN. So when the user logs into a service, a new session begins. The between session RNN looks at the previous sessions and outputs a vector, which is set as the initial memory for the within session RNN, which then can produce strong recommendations from the beginning of that session. So now the only missing piece is how we can, what the input to the between session RNN should be, because we need a way to represent the sessions. And there I experimented with two approaches for this. The first approach is to use the average of the interactions within a session. So remember that the item interactions in our case is only the item ID, and the item ID is represented as a one-hot vector. And the one-hot representation is very simple. If you have n items, then you use a n-dimensional vector to represent the items. So each index corresponds to one item. So item 3, for example, is represented by a vector where all the values are 0, except at index 3, where the value is 1. So here the session representation vector is simply the average of the item vectors for all the items within that session. And this representation represents the items fairly, because the representation vector will represent each item according to how often it appears in the session. This representation does not consider the ordering of the items. So another approach is to use what the within session RNN has learned about the session. So the memory vector of the within session RNN at the end of a session should be a pretty good representation of the session, because it contains information about the user's interests, and it also considers the order of the items. But it is biased towards representing the end of the session rather than the whole session. So I experimented a bit with both these approaches. They both worked well. It depended a bit on the domain, which of them was the best. So the results. This graph shows the recall at 5 score, which says something about so if the system gives you 5 recommendations, the recall at 5 score tells you how often the correct prediction was in that list of 5. So this is from the Reddit dataset, where the RNNs tried to predict the next subreddit that the user would be active in. And the blue line represents a standard RNN that only considered the actions within a session. And the red line represents one of the models where 2 RNNs were combined to consider both the items within a session and the session representations from recent sessions. The yellow line is just the difference between the red and the blue line. So you can see that the single RNN struggled at the beginning of the sessions, but after some time it's able to produce some decent recommendations. And we see that the inter-session RNN model is able to produce stronger recommendations throughout the whole session, and it also achieves a much higher score on the first time step. It actually scores better on the first time step than the single RNN is ever able to achieve. Yeah.
Yes, what kind of data set is this? Is this music?
This is a Reddit dataset where it's a log of which subreddits users commented in.
Yep.
So yeah. So I got similar results on the other two datasets as well, but a bit smaller difference on those, but still pretty convincing results. So yeah, that's what I worked on. Are there any questions? Okay. Thanks for listening.
Og her har du den. For å holde tale. Kan jeg låne mikken?
Ja.
Og den der.